Welcome to Ask and Learn.
So in this question, it asks us to construct truth tables for 5 possible compound propositions that are given to us. So let's start with the first one. This is read as, if proposition P inclusive or proposition Q, then proposition P exclusive or proposition Q. Let's get started with the truth table. So first, we're going to do each individual proposition, then each individual compound proposition. So P inclusive or Q, P exclusive or Q, and then the compound proposition total that we're doing. So with the conditional statement. P inclusive or Q, conditional statement, P exclusive or Q. So this will be the truth table. So now we just separate regarding what we're solving. So for the first propositions, we just write down the possible combinations. True, true, false, false. Now, Q is true, false, false, to give each possible combination. Now for the inclusive OR, we know that it is only false if both propositions are false. Anything else, it's true. So we could write it as true, 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 and since they're both false, false. Now for exclusive OR, we know that the rule is exactly one of the propositions has to be true. If both are true or if both are false, then it'll be false. So it's going to be false, true, true, false. Now to solve the entire compound proposition with the conditional statement, we know that the rule, if the first proposition is true and the second proposition is false, then it's false. Otherwise, it's true. So for these truth values, we know since the first proposition is true and the second is false, it'll be false. Since that combination does not occur again, everything else can be seen as a true truth value. So true, true, true. So this will be the truth table for the first compound proposition given to us. Now, let's do B. So let's get rid of this that we already solved for. Let's get rid of this one, which we solved for. All right, so B, we know is P exclusive or Q, conditional statement, P and Q. So let's go ahead and delete this one. Let's delete these. We could leave this since that's what's required. Actually, let's get rid of it. Let's get rid of it all. Start from scratch, except for this, which is what we need. All right, so same thing. We start off with the first compound proposition that we're using, P exclusive or Q. The second one, P and Q. And last but not least is the entire compound proposition. So P exclusive or Q in parentheses. Conditional statement, P and Q. So let's go ahead and split these up. All right. So exclusive or, as said before, exactly one of the propositions has to be true. No more, no less. So this will be false, this will be true, this will be true, and this will be false. Now for and, both of them require to be true. Anything else, it's false. So this first one will be true, the rest will be false. Now for the conditional statement, as said before, if this propositional statement is true and this one is false, it's false. Anything else, it'll be true. So the first one is true. Second one is true, false. So the truth value is false. Third one, same thing, will be false. Last one will be true. So this will be the truth value for B. Now let's do C. Let's get rid of this bad boy. Let's get rid of all of these. Okay, and let's get rid of this. So C, we know is P inclusive OR Q, exclusive OR P and Q. So we'll do the same thing, P and Q, P inclusive OR Q, P and Q, and then the entire compound proposition with the inclusive OR. So P inclusive OR Q, exclusive OR P and Q. So let's separate it to make it a little more easily visible. These three. All right. So inclusive OR, if both of them are false, then it's false. Everything else is true. So this truth value, true, true, and false. Now for and, they both have to be true. Everything else is false. So here we got true, and then the rest will be false, false, false. Now for the exclusive OR, exactly one of them have to be true. Anything else, it's false. So these first two, since they're both true, it'll be false. The next two, since exactly one of them is true, it'll be true, true, and the last one is false. So this will be the truth table for C. Now let's get rid of C. So do D. So let's get rid of that. Let's get rid of these. All right. Now D, we know is P, biconditional statement, Q, exclusive OR, the negation of P, biconditional statement, and Q. So we already have P and Q here. Now we need to do a third proposition, which is the negation of P. So we know that the negation of P, whatever the truth value of P is, the negation is the other value. So since this is true, this will be false. Since this one's true, this will be false. Since it's false, this will be true. And then since it's false, this will be true as well. Now we're going to do this compound proposition. So P biconditional Q. Let's write it down. P biconditional Q. And then this one, negation of P biconditional Q. And then the entire compound proposition. P biconditional Q. Exclusive OR biconditional, negation of P biconditional Q. All right, now let's do P biconditional and Q. So we know that for this one, so both of these propositions, their truth values have to be the same in order for it to be true. If they differ, then it'll be false. So for biconditional of P and Q, since the first one is both true, this will be true. Second and third one, they differ. So it'll be false, false. And the last one, they're both false, so it'll be true. Now, same thing for this compound proposition. Now, keep in mind, we're using the negation of P this time. So instead of looking at the first two columns, we're looking at the second and third columns. So here, the first one, they differ, so this will be false. The second row, they're both false, so this will be true. The third row, they're both true, so this will also be true. And the last row, they differ, so it'll be false. Now, exclusive OR, we know that both propositions on each side of the exclusive OR, there has to be exactly one of them true. If they're both true or if they're both false, then it's false. If exactly one of them is true, then it's true. So the first one, you could see first row, they differ. Second row, they differ. Third row, they differ. Fourth row, they differ. So they all are true. So this will be the truth table for D. Now, let's get rid of this and work on E. Should have done this. Let's get rid of all these. All right, so E, we know, or we see, is P biconditional statement, Q, exclusive OR, negation of P, biconditional statement, negation of R. So here we're introduced a new variable, which is R. So real quick, let's get rid of this, since now the combinations differ. So now we'll do P, Q, R. Since we're also using negation of P and negation of R, we'll do negation of P, negation of R, each compound proposition individually. So it's P biconditional statement, Q, negation of P biconditional statement, negation of R, and now the whole compound proposition. So P biconditional statement, Q, exclusive OR, negation of P, biconditional statement, negation of R. So since now there are three variables, there are going to be different combinations. So here we'll start with P, true, 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 then false, 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 false. For Q, it's true, true, false, false, true, true, false, false. For R, true, false, true, false, true, false, true, false. Now, the negation of P, you look at the truth values for P that we have here, and we know it'll be the opposite. So the first four are true, so that changes to the first four as false. The last four are false, so that changes the last four as true, true. Now, negation of R is the same thing. Whatever the truth value is for R, it'll be the opposite. So this alternates true, false, true, false. So this will alternate false, true, false, true, false, true, false, true. Now we solve for this compound proposition. So proposition P, biconditional, proposition Q. So we look at the first two columns, and we know that both their truth values have to be the same in order for it to be true. Anything else, it'll be false. So the first two rows, you see they're both true. So that means they're both true, first two rows. Second, third, fourth, and fifth rows, they differ. So those will be false. And then the last two rows are the same. They're both false. So that would be true. True, true. Now we look at the negation of P by conditional statement, negation of R. So those are the fourth and fifth columns that we're looking at. Again, both their truth values have to be the same in order for it to be true. So the first one, they're both false, so it'll be true. Second one differs, so that'll be false. Third one is the same, true. Fourth and fifth differ, so those two will be false, false, false. Sixth is true. Seventh differs, so it's false. And the last one, they're both true, so it's true. Now, we solve for the entire compound proposition. So exclusive or, again, we know that exactly one of the propositions has to be true for it to be true. Anything else, it'll be false. So the first one, these two are true, so that is false. The second and third, they differ. Exactly one of them is true, so they're both true. True, true. The fourth and fifth one, they're both false, so it is false. False, false. Next one, exactly one of them is true. The one after that, exactly one of them is true, so they're both true. True, true. And the last one, they're both true, so it'll be false. So this will be the truth table for E. Now let's get rid of all this in order to solve for F. So now we know that F is given as P exclusive or Q conditional statement P exclusive or negation of Q. So again, let's start off with the individual different propositions. So we know we have three. So we have P, we have Q, and we have the negation of Q. Now we do this compound proposition, which is P exclusive or Q. The next one is P exclusive or negation of Q. And then the complete compound proposition, P exclusive or Q, conditional statement, P exclusive or negation of Q. All right, so let's do the different combinations. True, true, false, false, true, false, true, false. Now the negation of Q, you look at the truth values for Q, and whatever that truth value for Q is, the negation is the opposite. So this will be false, true, false, true. Now, P exclusive or Q, exactly one of these propositions has to be Q for it to be true. Anything else, it's false. So we see that it'll be, these both are true, so it's false, true, true, false. The next one is the proposition P exclusive or negation of Q. So now we're looking at the first column and the third column. So this will be true, false, false, true, false, false, and false. Now we look at the entire combination. So this one will be true. Apologize. So the conditions, if this first proposition is true and the next one is false, then it's false. Everything else is true. So we look at the fourth and fifth columns. So false, true, this is true. True, false, it's false. True, false, it's false. False, true, it's true. So this will be the truth value for F.